Okay, welcome back friends. In today's video, I'm going to solve question 4 from November 2020 past exam paper. Okay, before I can start, I want to ask you to subscribe to our channel and activate the notification bell so that you can be notified every time I post new content for you. Okay, let's get started with the question. Okay, to solve this question, you will need the knowledge on hyperbola, parabola, linear, and inverse graphs. You will also need to know how to find the area of a trapezium, and you also need to know how to differentiate. Okay, so the question is from November 2020 past exam paper. Okay, we are going to solve it. So this is the question. You have two questions, 4.1 and 4.2. Okay, we'll start with the first question, 4.1. On 4.1, you have three sub-questions. Okay, this is the question, 4.1. Let's keep it here. Okay, we have three sub-questions to solve on 4.1. Okay, you are given an equation of an hyperbola. This is the equation, h of x. Okay, 4.1.1, the question says, write down the equations of the asymptote of h. So you need to write the equation of the vertical and horizontal asymptote. 4.1, 4.1.1. Okay, looking at the given equation, you can see the vertical asymptote is at x equal to 1 and the horizontal asymptote is at y equal to 2. Okay, so you just have to write down, but I can show you where the vertical asymptote is obtained. So the vertical asymptote is obtained when you make this part equal to 0. Like when you say x minus 1 is equal to 0. So you make the bottom part equal to 0 and then you solve for x. So from there, you're going to find your vertical asymptote. Can you see this is the bottom part, x minus 1 equal to 0. So you make it equal to 0 and then you solve for x. So that is your vertical asymptote. So what is x? X is equal to, when you bring the negative 1 to the other side, so x will be equal to 1. So this is the vertical asymptote. You can write it down by just looking at the given equation, but you can also show how to find the vertical asymptote as I have just shown you. Okay, and the horizontal asymptote is at y equal to 2. Okay, you obtain it here. So this is the answer to question 4.1.1. Okay, now the next question, determine the equation of the axis of symmetry of h that has a negative gradient. Okay, you need to determine the equations of the axis of symmetry of h that has a negative gradient. Okay, 4.1.2. Do you agree with me that the axis of symmetry is a line? So the general equation of a line is this one, y is equal to mx plus c, because it is a line, the axis of symmetry. Okay, so m is the gradient and c is the y-intercept. And you have two axes of symmetry for the hyperbola. So this is an hyperbola. The equation is an equation of an hyperbola. You have two axes of symmetry for an hyperbola. You have one which has got a positive gradient and the other one which has got a negative gradient. For the positive gradient, this is the equations you can see. Okay, I'll say this has got a positive gradient. And you also have this one which has got a negative gradient. Okay, you don't need this one, the one with positive gradient, because the question is asking you to write the one with negative gradient. So you need this one, the second one. I want you to be aware of something. For the axis of symmetry, their gradient is always equal to the value 1. Let me say that again. The gradient of the axis of symmetry of an hyperbola has got a value of 1. So it can be a positive 1 or a negative 1. So it is always a negative 1 or a positive 1 for the gradient of axis of symmetry of an hyperbola. So this is an hyperbola. the equation that we are given. The axis of symmetry will have a gradient of -1 or +1. Always +1 or -1. And you know the axis of symmetry is a line or a linear function. So this is why it is of this form: y is equal to mx plus c. So m is always equal to +1 or -1 for the axis of symmetry of an hyperbola. Okay, we are going to use this one because the question is asking us to determine the equation of the axis of symmetry of h that has a negative gradient. Okay, now you are going to determine C2. You don't know what C2 is, so you are going to use a point on the line or on the axis of symmetry. When using this equation of the hyperbola, the one you are given, there is a point 1, 2 on the line. So the point 1, 2 is on the axis of symmetry. Okay, you can see where did I obtain this? I obtained it from the equation here, the one given. So you have 1 for the x coordinate and 2 for the y coordinate. So this is on the axis of symmetry. You see this point 1 and 2, the axis of symmetry, the one with positive gradient and the one with negative gradient, and the vertical asymptote and the horizontal asymptote, they are all cutting through this point. They are passing through this point. Okay, I'm going to show you that when we sketch the graph in the next question. Okay, but for now we are trying to solve for C2. Okay, now we have this point. The point is on the axis of symmetry. We need to determine the equation of the axis of symmetry of h that has got a negative gradient. Okay, we're gonna use this one, the one with negative gradient. Okay, what is your y? Your y is 2. You know the second coordinate is y and the first coordinate is x. So your y is 2. 2 is equal to negative x. What is your x? Is 1, the first coordinate. So -1 plus C2. Okay. And now you can solve for C2. What is C2? C2 is equal to 2 plus 1 when the 1 moves to the other side. So you have 2 plus 1. And C2 is equal to 3. Okay. So now you have your C2. And what is now the equation of the axis of symmetry with negative gradient? It will be y is equal to negative x plus, what is C2? Plus 3. Okay, plus 3. Okay, now let's move on to the next question, 4.1.3. So 4.1.3. Sketch the graph of h showing the asymptote and the intercept with the axis. Okay, you need to show the asymptote and the intercept with the axis. Okay, let's get down everything you need for sketching the graph of h. So you need the asymptote of h, and this is the equation. H of x is equal to -3 over x minus 1 plus 2 there. Okay, so this is h of x. We need the asymptote of h. So you have the vertical asymptote at x equal to 1. Do you remember from question 4.1.1? And you have the horizontal asymptote, which is y is equal to 2. Okay, what else do we need in order to sketch the graph of h? We need the x-intercept. So to find the x-intercept, you let y equal to 0. Because you know at the x-intercept, y is equal to 0, right? Okay, so you're gonna need this. So remember, your h of x is your y. So y is 0 equal to, you have this, -3 over x minus 1 plus 2. Okay, so this is your y, h of x. We let it equal to 0. This is why you put 0 there, and then you say it is equal to this. And then now we're going to solve for x. So you take +2 to the other side, it becomes negative 2. Okay, so negative 2 is equal to this. Okay, and now you can do cross multiplication in order to solve for x. So remember, negative 2 is over 1. Negative 2 times this, so it's negative 2 times this, which is equal to, you have 1 down there, so it's negative 2 over 1. So the 1 times negative 3. There's 1 times the negative 3. So this times this, and the 1 down there times negative 3. So you do cross multiplication. Okay, let's carry on. So you have negative 2 times x. It will give you negative 2x. You have negative 2 times negative 1. It will give you positive 2, which is equal to negative 3. This is negative 3. Okay. And you have negative 2x is equal to, you have negative 3 minus 2 when the 2 goes to the other side. So you have negative 3 minus the 2. It will give you negative 5. Okay. Okay, now to solve for x, you divide by negative 2 on both sides. So when you divide by negative 2 this side, you have x is equal to negative 5 over negative 2. It will give you 5 over 2. Or you can say x is equal to 2.5 if you want to write it as a decimal. Okay, so this is the x-intercept. Now let's get the y-intercept. So to get the y-intercept, you let x equal to 0. You know that at the y-intercept, x is equal to 0. Okay, let me make a line here so that I can separate this. Okay, so now you let x equal to 0 to find the y-intercept. So you still use this, and h of x is your y. So you put y is equal to negative 3 over 0 minus 1. So you let your x equal to 0. So you're going to have this negative 3 over 0 minus 1. This is what we have, plus 2. Okay. And y is equal to, you have negative 3 over negative 1. This is negative 1. And this will give you 3 plus 2. And y is equal to 5. Okay, so this is the y-intercept. Now you have your x-intercept and your y-intercept, and you also have the vertical asymptote and the horizontal asymptote. Okay, what else do we need? You need to find where the hyperbola lies. So in which quadrant does the hyperbola lie? You can see this is your A, and this is your Q, this is your P. Okay, if you don't understand the notation A, P, and Q, I'll suggest you check the lesson on the hyperbola that I will post. So it will be under function. So your A, which is negative 3, you can see your A is less than 0. It is negative. This is your A. So when A is less than 0, as in this case, A is negative 3, it is less than 0, H lies in the second and fourth quadrant. Okay, so when A is less than 0, the hyperbola lies in the second and fourth quadrant. Okay, now we have everything that we need to sketch the graph. You have your vertical and horizontal asymptote, you have your x-intercept, you have your y-intercept, and you know in which quadrant the hyperbola will lie. So now let's sketch the graph of H. Okay, I have the graph here. Okay, so this is the graph of H. You can see there's the graph in black, the graph of H. You can see you have your vertical asymptote at x equal to 1. This is your vertical asymptote in red at x equal to 1. And you have your horizontal asymptote at y equal to 2. This is your horizontal asymptote, and this is your vertical asymptote. And you have the y-intercept there. So we find the y-intercept. Can you see? So you have the y-intercept there. You know at the y-intercept, x is 0. So this is the x coordinate and this is the y coordinate. The point there is your y-intercept. And you have your x-intercept there. We found the x-intercept. Can you see? It was 5/2 or 2.5. There it is. So the graph is cutting the x-axis at 2.5. So the coordinate of the x-intercept are 2.5 and 0. This is your x coordinate and this is your y coordinate. You know that at the x-intercept, y is 0. The graph lies in the second and fourth quadrant. We are done with question 4.1.3. Okay, I want you to see what I was telling you in question 4.1.2 about this point 1, 2. So the x coordinate is 1 and the y coordinate is 2. So this is the point 1, 2. This point there. You can see the horizontal and vertical asymptote are cutting through. They are passing through. And the axis of symmetry with positive gradient and the one with negative gradient, they are also passing through. This is why I used this point here to solve for C2. You can also use it to solve for C1. If you were asked to determine the axis of symmetry with positive gradient, you can still use this point. Okay. Now, if P and Q were equal to 0, your asymptote will be the y-axis and the x-axis. And the axis of symmetry, this one and this one, will be cutting through the origin. Can you see that? If P and Q were equal to 0. Okay, 4.2. Let's get the question. So this is the question 4.2. Okay, let me get it here. Okay, 4.2.1. Write down the coordinate of A, 2 marks. Okay, so this is A. You note A is the turning point. You can see A is the turning point. Okay, since A is the turning point and you are given the equation f of x in this form, you can get the turning point easily when the equation is given in this form. Can you see the turning point is at -5 and -8. So the x coordinate is -5 and the y coordinate is -8. Okay, so 4.2.1. Since this A is the turning point, using f of x, you know that the coordinate of A is -5 and -8 when looking at the equation. So this is simple. When it is given in this form, you can get the turning point easily. And you know A is your turning point. You can see they told you that A is the turning point. Now, question 4.2.2. Write down the range of f. So the range of this function f. You have f there. Can you see? You need to write the range. You know the range is found on the y-axis. Okay, 4.2.2. So the range will be all the values of y that exist for this graph of f. So it will be from, what is that point A? You just wrote the coordinate down. There are the coordinates. So you know that -8 is there. So from -8 going up, all those values, they exist for the graph of f. So below -8, you don't have values that exist for this graph of f. So you will say the range of f is y greater than or equal to -8. So you take all the values that are greater than or equal to -8. So you can see, why do we say that it is also equal to -8? Because -8 is included. This is why we say y greater than or equal to -8. Or you can say y element of this interval. So you have the square bracket and the round bracket. So from -8 to infinite, positive infinite. Because you know when going up there, you're going to positive infinite. So you start at -8, going up there to positive infinite. You have the square bracket because -8 is also included in the range of f. Now here you have a round bracket because you don't know what infinity is. It doesn't end. You still continue. So it is not like a number that you know because this graph does not stop here. You can see the arrows. It tells you that the graph still continue. Okay, I have said enough. Now let's move on to the next question. 4.2.3. Calculate the values of m and n. You can see m is the x coordinate of D and n is the y coordinate of D. You can also see that m is the x coordinate of D, E, and A. Can you see? From 4.2.1, you solved for the coordinate of A. They were -5 and -8. So this is your x coordinate, which is equal to m. So you know that m is equal to -5. So 4.2.3, m is equal to -5. Now you need to find n. What is n? Okay. So what is n equal to? Okay. Let me do this. Okay. You can see the point D is on the line G. Can you see? So since D, the point D is on G. Can you see? Do you agree with me that you can use g of x to find n? Because D is on the line G and this is the equation of G. Okay, so g of x is equal to this 1 over 2x plus 9 over 2. Can you see? And g of x is your y. And you know your y is the second coordinate, which is n. So we can say n is equal to 1 over 2. You plug in your x plus 9 over 2. Can you see? So n is equal to 4 over 2. And this is equal to 2. Okay. Now let's move on to the next question. Let me pull my question up a bit. Okay, 4.2.4. Calculate the area of OCDE. So there is OCDE. Can you see what shape is it? This is a trapezium. So you need to find the area of what? Of a trapezium OCDE. So 4.2.4. You need to find the area of a trapezium. So the area of a trapezium is equal to half of the sum of the parallel side times the perpendicular height between them. Okay, so you have your parallel side, this one and this one. So DE and CO, these are your parallel side. So you would say half of the sum of the parallel side times the perpendicular height between them. So let's call this side A and this one B and the perpendicular height H. So the area of the trapezium is equal to, you have half of the sum of the parallel side. You have the parallel side, you do the sum times the perpendicular height between them. Can you see that the coordinate of D can tell you what the length is from E to D? So you know N is the Y coordinate. So N is there and N is equal to 2. So that distance E to D is equal to 2 and this is A. Okay, we say A is equal to 2. And now you have B, which is OC. So if you know the y-intercept, you'll get the distance here. Can you see the point C is the y-intercept? And you can see the equation of G tells you that the y-intercept is 9 over 2. So B is equal to 9 over 2. And now you need your perpendicular height between the side. So you have this side and this side. Now the perpendicular height is this one, EO. Can you get the length? So the perpendicular height is H. H is equal to what? You know the x coordinate of E will tell you the length EO, right? So from the coordinate of D, the x coordinate M was equal to -5. So it is the same x coordinate of E. So the x coordinate of E is also -5. So from 0 to E, the length is 5. H is equal to 5. Okay. Now the area is equal to, and A, the area is equal to what? Now you need your calculator. Let me remove this for now. Okay, let me get the calculator to solve this. Okay. Let's get what the area is. You have 1 over 2 times, in bracket, you have 2 plus 9 over 2. I hope you can follow that. Times 5 outside of the bracket. So this is the answer, 65 over 4. Okay. So 65 over 4, we say square unit. Or you can say the area is equal to, when you want to write it as a decimal. So this is the answer, 16.25. 16.25. Okay. So the answer is 16.25 square unit. Let's move on to the next question. Okay, let me get the question. Okay, this is the question. Now it's question, let me put it here. Now it's question 4.2.5. Determine the equation of g to the power of -1, which is the inverse of g, okay, in the form y is equal to. So you need to determine the inverse of g in the form y is equal to. So let me put a line here, okay. And now we are going to solve 4.2.5. We need to find the inverse of g. So what is g of x? It's given, can you see? It is 1 over 2x plus 9 over 2. Okay, so this is g of x. Okay, first of all, what you want to do is to write g of x as y. And then you can now find the inverse of g of x. So this is the same as y. And this is equal to 1 over 2x plus 9 over 2. Okay, so you remove g of x, you put y. You know that g of x is the same as y. Okay, now to find the inverse of g of x, you'll swap the x and the y. So where you have x, you put y. Where you have y, you put x. So I'll put x there. Can you see? I'm using a different color. So where there's y, I put x. And this is equal to 1 over 2. Where there's x, I put y. Can you see? I'm using a different color. Plus 9 over 2. So you exchange your x and y. Now you can solve for y. You have 1 over 2y there, which is equal to x. Can you see? 1 over 2y, which is equal to x. And you bring this 9 over 2 to the other side. It becomes -9 over 2. Can you see that? And now you continue. You want to solve for y. To solve for y, you have the coefficient of 1 over 2. You are going to multiply by 2 throughout so that you can solve for y. So when you multiply by 2, you get y. Can you see? 2 times half will give you 1. So it's 1 times y, it gives you y, which is equal to, this times 2 will give you 2x minus, now you have 9 over 2 times 2, the 2 will cancel, you will have minus 9. Okay, so this is the inverse of g written down in the form y is equal to this, what we have here. Now let's move on to the last question, 4.2.6. This is an interesting question. 4.2.6. Let me get the question again. Now, on this one, I want you to pay attention to the way I'm going to explain this. The question is saying if h of x is equal to, this is the inverse of g of x plus k. Can you see that? And h of x is what? Is a tangent to f. Can you see that? Determine the coordinate of the point of contact between h and f. So h is the tangent to f. Okay, let's do it. It's not a complicated question. So you have h of x is equal to the inverse of g of x plus k. This is what you are told here. And this is a tangent to f. So remember the inverse of g of x from the previous question was this. Can you see? We calculated it in the form y is equal to 2x minus 9. When you look at the question 4.2.5. Okay, and you also have f of x. We are going to need it. F of x is equal to this. This is what we have here. So h of x is equal to, now let's replace the inverse of g of x. So we're going to replace it with this. So the inverse of g of x is 2x minus 9. You have plus k. Okay, so this is h of x. You can see from there we have this. And this is still the tangent to f, right? Okay, so I can remove this. You don't need it. Now remember that a tangent is a line. Do you agree with me? A tangent is a line. So it is a linear function. Okay, so t, let's use t for the tangent, is of this form, mx plus c. Since it is a line, remember this is a general equation for a line or a linear function. Now the gradient of the tangent, this is the gradient of the tangent, which is m. Do you agree with me? So m, the gradient, is equal to 2, and negative 9 plus k is equal to c. Now this is the part I want you to remember, to always remember what I'm going to put down. Now the gradient of a tangent, I have the subscript t to mean the gradient of a tangent. So m is the gradient and t means the tangent. The gradient of a tangent is equal to f dash of x or f prime of x when you have a tangent to a curve. So it can be a tangent to a circle, or a tangent to a parabola, or a tangent to any curve. So this is f prime x. Let's find f prime x, or the derivative of f of x. So what is f of x first? This is f of x. Let's expand the bracket and then we can find the derivative of f of x. Now from here, you can find the derivative. Okay, I'm not going to waste time to explain how to find the derivative. So there will be a lesson on calculus where I'm going to explain this. As for now, let's find f prime x, or the derivative of f of x. Okay, so this is equal to, you bring 2 times the coefficient there. So 2 times half, it's 1. And then x to the power of 2 minus 1, which is 1. So you have x plus, you have 1 there. So it is x to the power of 1. 1 times 5 is 5, right? And x to the power of 1 minus 1, which is 0. So x to the power of 0 is 1. So you have 1 times 5, it's 5. And this is a constant, it is 0. So this is the derivative of f of x. Okay, now let me put a line here to continue over here. So now you are going to need this to find the point of contact between the tangent and the parabola. So this is what you need. And what is the gradient of the tangent? So what is the gradient? Is 2. This is equal to 2. is equal to f prime x. So it's x plus 5. And then now you can solve for x. So x is equal to 2 minus 5. 2 minus 5 is negative 3. To find the y coordinate, you are going to plug in the x coordinate in f of x or in h of x, because you know that the tangent h and f share a common point. So they have the same x coordinate and the same y coordinate. So you can plug in f of x or h of x to find the y coordinate. Okay, I can't use h of x because I don't know what k is. Okay, so I'll say f of negative 3. So this is your y. Y is equal to negative 6. So the point of contact of f and h is negative 3 and negative 6. Okay, we are done with question 4 from November 2020. I hope it was helpful. If you did find some value in this video, please appreciate that with your likes and comment. And if this is the first time to this channel, don't forget to subscribe to your channel. If this was not the first time to this channel, it was nice to see you again. Okay, you can see down below is my name and the email address at which you can contact us. If you have any question or anything that you would like to let us know, feel free to use the email address down below. See you next time and take care.